All right, hello. This is our presentation about the Antikythera mechanism. My name is Joseph, and we'll just go around the room. Whoever wants to go first with their name.
I'm
I'm
Connor
Catherine.
McAvoy. Oh,
Sorry.
it's all good.
And I'm Andrew.
Um,
Okay, so today we'll be discussing the Antikythera mechanism, its history in terms of how it was discovered, what its implications were, and about the mechanism itself, how it functioned. So to begin that conversation, I'd like to start with Connor, who has prepared something about the actual discovery itself. So Connor?
Perfect, thanks. So first thing I wanted to touch on is the sort of sponge divers situation and how they sort of came across it, which is kind of weird. It seems like they were just off the coast. They were sort of docked off the Greek island of Antikythera, and they just sort of went dive in to see what would down when it was down there to see if they could get a little lucky with anything there, and they came across a number of artifacts down there, and one of them, of course, being the mechanism, and this was in the year 1900, I believe. So here, the archaeologist Valerio Stais, I hopefully didn't butcher that, was one of the first to observe the piece of rock that had the gear wheel embedded in it, which is a staple of the, of course, Antikythera mechanism. Um, and this discovery sort of brought along with it a lot of early hypotheses about what the mechanism would be. So some of these things would be for the potential of it to have been too complex and maybe was created, not as long ago as people had originally thought. Um, they also thought it could even be a hoax, or perhaps even an astrolabe, which is an instrument formerly used to make astronomical measurements, pretty much like the altitude of like planets and the sun and the sky, as well for navigation, for latitude, longitude, things like that. This was before the sextant, of course, and sort of like boats and how they sort of went around the sea. Also, they sort of thought that a possible Babylonian origin. This is something that was thrown in and out as a possibility. Um, if true, with the Babylonian origin, this would make it significantly earlier than the Greek theory that's currently, I guess, most used today. Also, other theories that centered around it have it going back to the Greek city of Rhodes, where philosopher Posidonius had an astronomy school that was fairly famous, where it's possible that a vessel leaving the island of or leaving the city of Rhodes sank with the mechanism, and then that's of course where it ended up until around 1900. In addition to that, some of the advancements in technology that had to happen for this mechanism to truly be deciphered. Some of these were, of course, like X-ray imaging in the 1970s. This allowed for like the first, I don't want to say high-res images because they absolutely were not high-res images, but some good images that scholars were able to see. However, of course, these images weren't good enough, so it wasn't until the later CT scans in around 2006 where scholars got truly excited about this because you could see its inner workings much easier, and they were also able to decipher some inscriptions on the mechanism, which definitely made it a lot more of something that scholars were a lot happier to see. So next off, I'm going to go ahead and pass it over to.
To me, yes. Uh, Okay, so thank you, Connor, for giving us the background on this machine and its discovery. I'll be discussing the physical and mechanical structure of the Antikythera mechanism, and to do so, I'll be putting up some pictures in the background. So I will take care of that right now. Good, right there, perfect. So the first thing that's important to immediately make clear is that the Antikythera mechanism functioned like a clock, and the only way to input information into the machine was through a tiny hand crank on the side. We call it the world's oldest computer because a computer, by definition, is a device to store data. And amazingly, the Antikythera mechanism did this in a wooden case roughly the size of a shoebox. So from the X-rays of the pieces that we do have, combined with suggested recreations of the device, researchers now assume that the side crank put into motion at least 30 interconnected bronze gears. Determining the number of teeth on the gears and their composition was very important because these numbers often corresponded to phenomena in the natural world. For example, the earliest researchers noted that the main gear had approximately 235 divisions, which correspond to the 235 lunar months that make up the Metonic cycle. Another gear, which was of early interest, was a much smaller one with only 127 teeth. By connecting this gear with the others, it's hypothesized that the creator was able to double its effect, thereby creating a series of gears with a combined effect of 254 teeth, that represent the 254 orbits of the moon in the Metonic cycle. So with all of that packed inside, the machine conveyed information on both its front and back panels. The front panel, which I'm going to discuss first, is believed to have tracked celestial time. 5 pointers would rotate in a circular motion that had balls of different colors attached to them. We understand these now to be the 5 planets visible to the naked eye, which are Mercury, Venus, Mars, Jupiter, and Saturn. There is also a pointer for the sun, which was the main indicator of time, as the Greeks had a geocentric understanding of the universe. Finally, there is another pointer painted black and white to show the position and phases of the moon. As all of these features rotated, they would align with markers on the 2 outer rings. One was labeled with the days of the Egyptian calendar, and the other was with the 12 signs of the zodiac. As one can imagine, it was very difficult from a mechanical standpoint to have all of these parts working in tandem, but I think this diagram of a proposed structure makes it a bit more clear. Essentially what was going on is that you had several discs with attached pointers, and they were laid over a rod that had bolts of different shapes attached to the base. The middle of the discs were then indented with the corresponding shapes and were independently controlled by separate gears, and this meant that the pointers could rotate at the various speeds of the celestial objects. Now, the back was much more complicated. There was 2 large discs that each had additional dials inside of them. The top disc was engraved in a circular pattern with the periods of the Metonic cycle, and also featured a smaller dial inside to depict the 4 Calippic cycles. Both of these cycles could have been used as ways of regulating the solar calendar, as the Metonic cycle relied on adding a periodic 13th month, whereas the later Calippic cycle created a 76-year calendar with an amazingly average year of approximately 365 days. Inside this disk, we also see another smaller dial with the rotation of the Pan-Hellenic Games. The bottom disk depicted the Saros cycle, which is a period of nearly 19 years in which the sun, earth, and moon realign and create solar and lunar eclipses. There is also a minor disk inside that one, and that showed the Exeligmo cycle, which is a triple Saros cycle. The creator likely included the secondary dial because, as I said before, the Saros dial was nearly 19 years. So the combination of both cycles would allow for the user to determine the near exact time of an eclipse and account for various mathematical irregularities. Because the back of the device calculated the eclipses in accordance with the Saros cycle to determine the celestial time, all the user had to do was just turn the device around and look at the front, as all the gears were internally connected. So the bronze panels, additionally, were inscribed with what is now called the mechanism's instruction manual. The instructions were in Koine Greek, but due to heavy corrosion, it has been extremely difficult for researchers to understand the message the creator was attempted to convey. But regardless, the deciphered words appear to support the assumption that the Antikythera mechanism was measuring various cycles, as it seems to tell the user how to interpret the panels after cranking the main gear. So with all of that established about the actual mechanics of the machine, I'd like to pass it off to the next person who will be discussing a bit more about what this actually meant for the ancient Greeks.
Thanks, Joseph, for describing the mechanics of the machine. And now I'm going to talk a little bit about the function and the symbolism of the Antikythera machine to the ancient Greeks themselves. So it actually served, as Joseph was saying, a very specific function for the ancient Greeks. Principal function being to keep track of time. The device was a functioning astronomical calculator that actually kept track of the 4-year cycle of the early Olympiad games that we have talked about in class. So archaeologists first linked the computer and the games after an inscription of the word Nemea was discovered near a small subsidiary dial on the device. The Nemean games were one of the premier competitions in the Olympiad cycle. So later on, further inscriptions of Isthmia, I probably got that wrong, designating for Corinth, Pythia for Delphi, and Olympia, all confirmed the device's links to the Olympic calendar. These marks on the dial confirm the dates of a variety of athletic events, including a minor event in Rhodes that actually gave some evidence as to where exactly it was built, as Connor discussed. So the astronomical calendar represented more than just the Olympiad cycle, though. It divided a 360-day year into 12 months of 30 days, plus an extra 5-day period. It included a 360-degree dial that kept track of the zodiac cycle, dividing it into the 12 signs of the zodiac and splitting it into the fast zone and the slow zone. These zones supposedly kept track of the varying speed of the sun. as it rotated around the Earth. The 7 pointers that are included on the mechanism show Mercury, Venus, Mars, Jupiter, Saturn, and both the sun and moon's positions in the sky, as well as on the zodiac cycle. Using these, the Greeks were able to make forecasts of both lunar and solar eclipses, as well as forecasts for the weather for specific regions. So Greeks actually viewed astronomical events and day-to-day events like weather as inextricably linked. Another function of the mechanism, however, is more scientific. The black and white ball that is just below the moon pointer represents the moon phases and includes an important astronomical model, the moon's elliptical orbit around the Earth, rather than circular. And interestingly enough, this was actually at odds with ancient Greek philosophers of the time, and their belief that all astronomical objects orbit in perfect circles. This function helped kind of clarify what role the mechanism played in ancient Greece and provided an answer as to whether it was more of a scientific or philosophical instrument. It was, in fact, scientific and used primarily as an astrological clock. So obviously this object was very important and significant to ancient Greeks and is equally so for our study of them. So I'm going to throw it over to Catherine to talk about what it means for our study of them.
Yeah, thanks, Andrew. So as you said, I'm going to talk a little bit about the significance of the Antikythera mechanism. So clearly it's a really significant find because it shines light on a much more advanced technology that we previously had no idea that the Greeks possessed. So there will be nothing of this caliber of technological advancement until the 14th century. So this technology was lost for thousands of years. As of now, there is no other physical evidence of any sort of mechanism that does what the Antikythera does. There have been no similar artifacts found in the ancient world to this mechanism. However, it's pretty clear that this object was not the first of its kind, as it's very advanced and efficient. So there must have been many other trial runs that were not as efficient and accurate that have been lost to the archaeological record. While there are no physical remains of the device similar to the Antikythera, there's evidence of them in the written record. Cicero wrote of a bronze device that was made by Archimedes in the 3rd century, which served a remarkably similar purpose and was likely using the same technology as the Antikythera. The possibility that this technology is much older brings into question who originally discovered the technology. As Connor and Andrew touched on a little bit, some scholars argue that this device was most likely Greek because of its inclusion of the Olympics and other smaller Greek athletic festivals on the calendar, as well as where it was found and the artifacts around it in the shipwreck. However, others believe that this tool was created by the Babylonians. James Evans, an astronomer, thinks that the eclipse cycle represented in the device is Babylonian in origin because of its beginning date of 205 BC, as well as the way that it lines up with the Babylonian astronomical system. The idea that this mechanism was not the only one of its kind, and given how advanced it is, causes us to reevaluate what we know about the Greeks' technological abilities. Other than the question of who made it, there's also the question of what they could have done with it. One of the biggest inventions that led to the Industrial Revolution was the invention of gears and the harnessing of that technology. So it's pretty crazy to think about what the Greeks could have done with this technology if they had had more time to harness it. So yeah, thanks for watching. That was our presentation on the Antikythera mechanism.